back. In this session, we are going to see about simple search algorithms and also uninformed search. So in our last session, we have seen what is the generate and test. So based on the generate and test algorithm, it is a high level algorithm, and in that algorithm, we have seen moveGen function and also goal test function. So we are going to use those moveGen function and goal test function in all the algorithms. So in this simple search algorithm and also uninformed search algorithms. Coming to simple search algorithm, in this algorithm, our main task is very simple. So we have to find for a particular goal node in the given graph. So in this example, we can see they have given a graph. So this graph is called the tiny search problem. So in this one, the start node is S. So S is a start node, and we have to find for the goal node, that is G. So G is our goal node. So in this algorithm, we have to go from start state to goal state. And in this algorithm, we don't have any information about which path to take. So it will come under the blind search. So in this algorithm, so what we are going to do is, first we will select any node. We will take an open data structure. So it is a bag-like data structure in which all the elements will be there in that open. So in that one, randomly I will select one, while deletion I will select any node from that open data structure. So here, so in this algorithm we can see, this one is the open. We have created some open bag-like data structure. So in that one, initially the initial condition is we will start from starting node. So whatever the starting node is, it will be passed on to the open. So in open, initially we will be having the starting node. So after that one, we will have a while loop from this second statement to eighth statement. So second statement is a while loop open condition. So while loop condition, and eighth one is a fail condition. So in this one, that is between 3, 4, 5, 6, 7. So these all are come under while loop. So this while loop, we are having a condition such that, until this open is not empty, that is, this while loop will be executed until open is empty. So first one, in this simple search algorithm, we are going to take one particular element from the open data structure, and after picking up the particular element, we will check whether it is a goal node or not by using the goal test function. So we apply the goal test function on that particular node, and based on the result, we will move forward. If the particular goal test condition is true, then we will return the node, whatever the node that has passed that goal test function, we will return that particular node. So when it was not a goal test condition, that means the goal test function has failed. So in that condition, we will explore all the successors of that particular node. So the node can be anything. In this example, first, we will see S is the starting node and G is the goal node. So this algorithm, we can see in this algorithm, first open, first condition is a initializing condition, and next while loop, it will be executed until open is not empty, and after that we will pick an element from the open. So it can be random. So we will randomly pick a node n from the open, and we will delete that particular node from open, so that we have processed it. So after that we will process it. That is, we will test whether it is a goal node or not. So if goal test of n equal to true, then we will return that particular node. Else, then we will add all the successors of that particular node n. So that the successors of node n will be coming through moveGen function. So we will apply moveGen function on that particular node n, and we will add all the successors to the open. So this is the algorithm. So now we will work out this algorithm on this tiny search problem. So initially the starting node is S. So open, in this open, initially we will be having S. So S first, we will pick an element. So we have picked S. So there is only one element in the open. So while we will pick that particular element only. So we will pick S. So S will be picked and it will be stored in node N. Next, this S will be goal test condition is applied on S. S is not a goal function, goal node. So it will come false. So then we will directly go to else part. So else part is we have to apply moveGen on S. So if we apply moveGen, on S, so the output will be, so from S there are adjacent, the adjacent vertices for S is A, B and C. So when we apply moveGen function, we will get A, B and C. So these three will be added to open. So after deletion of S, so A, B, C will be added. So next we will again while condition will be checked, is open empty. So open is not empty. Currently open is having A, B, C. So we will try to this loop will be executed one more time. So we will pick a particular node from the open. So in open there are A, B, C. So randomly we will pick. Let's say I have picked B. So B will be picked and it will be stored in node N. So after that B will be deleted from the open. So from open B is deleted. Next, the goal test condition will be applied on B. So goal test of B equal to false because B is not a goal node. So we will directly go to the else part. In else part we have to apply moveGen on B. So if we apply moveGen on B, so the output will be, so from B we are having adjacency, the adjacent vertices for B are S, A and D. So S, A and D. So these three nodes will be again added to the open. So open again added to open. So already in open there is A, C. So again S, A and D are added. So again we are going to check whether while condition, so open is empty or not. So open is not empty. So again one more time execution will be going on. I have to pick an element. So in from these elements, that is A, C, S, A, D. So in these elements, let's say I have picked D. So I have picked D. So this D will be stored in node N. So after that one, we have to delete node D from the open. So from open, I have deleted D. So then I will check the goal test condition on D. So the goal test condition on D is false because it is not a goal node. Then we will directly go to the else part and we will apply moveGen function on D. So if we apply moveGen function on D, so the adjacent nodes are B here. So B for D, the adjacent nodes are B, C, G and E. So these things will be added. So there are 4 nodes. So 4 adjacent nodes. These 4 adjacent nodes will be added to the open. So those are first one B, next C, B, C, E and G. So after adding adjacent vertices of D, so the open will be consisting of these elements A, C, S, A, B, E, C, G. So in this from these elements, so open is not empty. So while condition was true. So the body of the while is executed. So that is we have to pick a node from the N. So pick a node from node N from the open. So let's say I have picked G. let's say I have picked node G. So this G will be stored in node N. So after that I will remove this G from the open and I will test the G node. So I will test goal test condition on node G. So after testing, so as G is a goal node, so this condition will be true. So this condition will be true. So after true we will return N, that is we will return G. So we will return G. So if we apply simple search 1 algorithm, then so this is the working flow of the algorithm on the tiny search problem. Here the drawbacks are, so it may go into infinity loop. So we can see here, so every time if I am selecting, if I am picking a node from open, so whenever if it is not a goal node, then I will apply moveGen function on that particular node. But already some elements can be already we have processed and they can be, so we don't have any data about what are the elements or what are the nodes we have already tested and which are false. So those details were not there. Because of that we will keep on picking up whatever the already picked up node is there, we will try to pick it up. So we will see an example for that instance also. So for this, so for in this tiny search problem only, so initially the open will be having S. So next I will pick S. So after I picked S, then so this is step 1. In step 2, so I have picked S and S is not a goal node. So the adjacent nodes will be added, that is A, B, C. In this one there may be a chance I will select A. So after selecting A, so what are the adjacent vertices of A? S, B and E. So they will be added. So after that initially BC is already there. For that one I will add S, B, E. So they may, in this particular instance, if I again selected S, so after selecting S is not a goal node, and then S will be, we will try to, so whatever we will apply moveGen function on S and we will add them to open. So after that one, so BC, BE, these elements are already there. So after picking S, what are the moveGen function, what are the adjacent vertices of S are A, B, C. So this A, B, C are added. Again, if I am again picking up, if I again picked up A, so what happens again? So this S, what are S, A is not a goal node. So we will, so yeah, this A is not a goal node. So we will add what the adjacent vertices of A. So the adjacent vertices of A are S, B, E. So these will be added. So from this one also again, so we will, if this is the cycle, then we are stuck in a loop, that is we are going from S to A and we are going from A to S. So like that this infinity loop may exist in the simple search one. So this is simple, whatever the drawback we have, so this drawback infinity loop will be eradicated in simple search 2 algorithm. So this is the simple search 2 algorithm. So in this algorithm we have updated, so we will be having 2 data structures. One is open, that is a back data structure, and also we will be having closed data structure. It is a set data structure in which we will store, so whatever the elements we have already processed, so those elements will be stored in closed. So the working is same to same as the SS1, that is simple search 1 algorithm. So we will try to open, so we will initial conditions will be open will be having start and closed will be having so nil. So that is no elements will be there in the closed data structure. Next while condition. So this while will be executed based on the condition, that is open is not empty, that is until open is empty. So this while loop will be executed. So after that one, I will try to pick an element from the open. So after picking an element, the node n, so that particular node n will be first, it will be deleted from the open and it will be added to the closed data structure. So just next, so goal test condition will be applied on node n, and then if it is true, then we will return n. So if it is not true, then so we will try to add we will try to apply moveGen function on that particular node n, and we will add them to open after deleting whatever the elements that are in the closed data structure. So already the processed elements will be in the closed. So while applying moveGen function, so whatever the output of moveGen function, from that one I will try to so delete whatever the elements that are already in the closed. So after deletion, whatever the result that can be, it will be added to the open. So this is simple search 2 algorithm. So simple search 2 algorithm example, it was the same example, that is a tiny search problem. So for this tiny search problem, so this one is a, so we can, so this algorithm can be done in 2 ways. So one is tree, using search tree, and another one is using so data structure like, so that are open and closed. So first I will explain this open and closed data structure. So in the algorithm we are initially, so we will be having so s equal to 0 and closure will be having no elements. So after that one, so I will pick s. So I have picked s. So this underline denotes so whatever the picked item. So s was picked. So after s was picked, I will check whether s is a goal condition or not. So goal node or not. S is not a goal node. So we will apply moveGen function on s. So if I apply moveGen function on s, we will have a, b, c are the adjacent vertices of s. So these three will be coming as a output for the moveGen function of s. So in that one, I have to delete any elements that are in the closed data structure. So from as closed data structure is empty, so I will directly add all the elements, that is a, b, c to open. So here I have added a, b, c to open, and I have added s to closed. So after that one, so I have picked some a. So let's say I have picked a. So from after picking a, I will check whether a is a goal node or not. So a is not a goal node. So we will I will apply moveGen function on a. So if I have applied moveGen function on a, I will get s, b and e. So s, b and e. So after s was already in the closed, so s will be deleted, and also b was already in the open, so b also will be deleted, and what are the remaining successors of a is e. So e will be added to open. So b, c are from the already there in the open. So in this step I have added e. So after deleting the, so what are the from the closed, so the elements that are already in the closed is yes. So I have deleted s, and also b was already in the open data structure. So I have deleted b also. So after that one, I will add a to the closed. So in the next step, let's say I have picked so c. So let's say I have picked b. So after picking b, so I will check whether b is a goal node or not. B is not a goal node. So b is not a goal node. So the successors of b are so s, a and d. So if I apply moveGen function on b, I will get the output will be s, a and d. So from this s, a and d, so both s and a are already in the closed. So I will directly ignore the s and a, and I will add d. So this d is added. So d is added to the open data structure. So in the next step, so the elements that are in open are c, d, e. I will try to pick any element. So let's say I have picked d. So I have picked d. D is not a goal node. So I will check whether D is in a goal node. It is not a goal node. So I will apply move gen function on D. So if I apply move gen function on D, so the elements will be B, C. So the B, C, D. Sorry, for D, B, C, E, G. So 4 successors are there. So among those 4 already, so B is in closed data structure. So I will ignore B. Next, C was already in open data structure. So C will be ignored. Next, E was also in the closed data structure, open data structure. So E also ignored. So then I will add G. So remaining element is G. So G will be added to the open. So after adding G to open, so the elements that are present in open are C, G and E. So this C, G, E, in this C, G, E, so I will try to pick a node. Let's say I have picked. So I am telling so any item can be, I can pick any item. That is C can be picked, G can be picked and also E can be picked. So in this one I am telling I am picking G. So after picking G, I will test the goal test condition. So this goal test G will be true. So I will return G. So this G will be returned. So this program returns G. So this is the working of SS2, that is simple search 2 algorithm on tiny search problem. So if this same scenario is represented using tree, so we will, if we want to represent the same scenario using tree, it will be represented like this. In the initial step, open will be having only S. So this will come under step 1. So in this step we are having only S. So after that one I will pick S and I have searched whether it is a goal test or not. S is not a goal test. So we will apply move gen function on S. After that I will add all the adjacent vertices to S. So for S will be parent node now, and so the successors of S will be added as so children of S. That we can see A, B, C are added for S. So in that one, this I have picked A. So to denote that one, so it is denoted like this. So after that one, so next step is A is not a goal node, and whatever the adjacent vertices are, what are the successors of A are, so S, B and E. Already S was there and also B also there in the tree. So I will directly add E as a children of A. So it was denoted here. So S, C, B, A for A, E is there. So we can see this dark circle and double circles. So a dark circle represents the starting node, and this double circle and dotted, so shaded node denotes it was already in the closed data structure. So next I have picked B. So B is not a goal node, and I have to add the adjacent vertices of B. So for the adjacent vertices of B are S, A and D. So S was already there and A was already in the closed, and I will add D. So it will be denoted here. So after that one, next step I have selected D. So D was selected, D was not a goal node. So I will add the successors of D by deleting already elements which are in the open and closed. So the for D, so B, C, D, E and G, 4 successors are there. In that one, B was already in the closed and E was already there in the tree, and also C is also there in the tree. So we will directly add G as a child node for the D. So it was represented here. So after that I will here we have selected G. So this G was selected. So after selecting G, so I will apply goal test condition on G. Here it will come true and I will return G. If the same algorithm can be applied, it can be shown using search tree also. So for the same example we have seen both search tree representation and also data structure representation. The disadvantage of simple search 2 algorithm is it will find out the goal node in finite search space. But if we are in that situation, whenever the particular goal node was found, so we will directly return the goal node, but not return the path for the goal node. How the path from starting node from goal node, how we have traveled. So that path was not given to the, so wherever it was required. But as we know, so we don't need the goal node in many cases. In many cases, we have to know whatever the optimal path or whatever the path is. So to find out the what is the particular path, so we will go for the simple search true. So in addition to simple search true, there is no path. So this path will be added in this simple search 3 algorithm. So in this algorithm, so we will take same, the algorithm was same. So the only difference is, so while storing the particular node, so I will try to store the parents of the particular node. That is, if I want to store S means for S there is no parent, so S can be directly, so S can be directly stored. So if I want to store A, so after I have applied Move function on S, so the elements, the output of Move function on S is A, B and C. So to save A, B, C, I will save as A is the particular node and its parent node, so AS, and B is the particular node and then its parent node S. Next, C is a particular node and its parent, that is S. So like this one, I will try to store the particular nodes in, so that whenever I needed, whenever the goal node was reached, so I will directly get the path from it. So these are same, the working is same. So here we have used, so mapcar function was used. This mapcar function is used to extract the first bit, and so that we can check whether the particular, it will take 2 or 3, so 2 or 3 lists, and in that one it will try to get the first bit and it will check. So this is the algorithm. So I will try to apply this algorithm in this tiny search problem. So this, in this SS3, it will maintain entire path information at each node, so by using this particular format to store the nodes. So here this SS3 was implemented here. So this tiny search problem was implemented using data structures, that is in open data structure and closed data structure. In open data structure, we are having only as it is a initial condition. So first step is the initial. So initial condition. So in this initial condition, so open will be having, so start, and closer will be having nil. So here open is having the starting node here is S. So S will be stored in open, and in the closure no elements are stored. So I will apply goal test function on this S. So if I apply goal test function on this S, so it was not a goal node, so it was false. If condition will be false and else part will be executed. So else part is, we have to add S to the, in the first step we have to add S to the closed data structure. So I have added S to closed data structure. Then I will apply Mugen on S, so that we can get the successors. Though it was stored in successors, it was stored in successors. So for the Mugen function on S is A, B, C, all the nodes, the output of the Mugen function on S. So they will be stored in successors. So in these successors, we have to whatever the open in the open data structure. So what are the elements are there? So those elements will be deleted, and also we will delete. So what are the elements that are present in the closed data structure? So initially the closed is empty. After deleting S, open is also empty. So this A, B, C elements will be directly added. So instead of adding A, B, C, we will add like AS, BS and CS, because AS we will come to A using S. That's why AS has come. Similarly BS and CS. So in closed, S will be added to closed. So after this step, so open will be having 3 elements. So that is A node, B node and C node. So we have to pick any particular node. So if I selected, so in this case I have selected, so let's say I have selected AS. So this AS will be picked, and from this AS, so I have to apply goal test condition on A. So for that one, it was stored in H. So from head. So whatever this node, in this node, whatever the head is A. So this head is stored in H, and we will try to apply goal test on that particular H. So A, we will apply goal test condition on A. A is not a goal node. So for we will apply move-gen function. So before applying move-gen function, we have to move that particular A to the closed data structure. So A will be moved to closed, and next, so I will apply move-gen function on A. So if I apply move-gen function on A, S, B and E will be the output. So S, B and E in this one, so already in closed S is there, so S is ignored, and also B, S, B and E. So S was already in the closed, it was ignored, and B was already in the open, so it was also ignored, and E was not in the open, so E will be added like, so E's parent is A. So while storing A, we have saved AS, so we will directly store EAS. That is, I have came to E from A and A coming from S. So this is the structure. So here I have added EAS to the open. So after this one, so again while condition will be checked, open was not empty. So we will try to pick an element. So let's say I have picked BS. So this BS will be picked. In that one, I will extract the first node, that is B, and I will apply goal test condition on that B. So B is not a goal node. So B will be moved to closed. So here B is moved to closed. After that, so I will apply move-gen function on B. So I have applying move-gen function on B. So that is output will be S, A and D. So these 3 elements. So in that one, first I will delete any elements that are in the closed. So in that one, any closed means S was already in closed and also A was already in closed. So I will ignore S and A, and I will select D, and it will be stored in successors. After that one, if any node that is present in open, we will check, but D was not in open, so D is added to open. So D, B, S. So this node will be added. So DBS will be added. So in this one, let's say I have picked DBS. So I have picked DBS. So D will be extracted, and goal test condition is applied on D. So goal test was a failure because D is not a goal node. So I will move D to the closed data structure. So I have moved D to closed data structure. After that one, so I will apply move-gen function on D. So if I apply move-gen function on D, we will get B, E, C and G. So these 4 nodes will be coming. So in these 4, I will first try to delete what are the elements that are present in closed. So B was already in closed, B was ignored, and next E, C, G will be stored in successors. So after that one, I will try to delete the elements which are already present in the open. So using this statement. So here, so E and C. So C was already in the open using C, and also E was already in open. So I will ignore C and E, and I will directly add only G. So this G will be added. So G parent is D, and whatever D's parent is B and B's parent is S. So this GDBS will be added to open. So we have added GDBS. So now we are having three elements, that is CS, GDBS and EAS. So in these three elements, let's say I have picked GDBS. So this G will be extracted from that node, and that we will apply goal test on that particular G. So there we will have true. So after true, so we will try whatever the node that was stored, that is G, D, B, S, we will reverse that particular order. So if we reverse it, so we will have S, B, D and G. So the path is S, from S we have gone to B, after that B to D, after that D to G. So this is the path. So by using simple search tree algorithm, we have got the path. So what in simple search tree, this the disadvantage is we cannot have any path. We will if the goal node was reached, we will say, let's say we will say that goal is reached, and we will return that particular goal node only. So by using simple search tree, we can also return success, stating that we have found the goal node, and also we can give the path. So this path will be given, that is S, B, D, G. This path will be given to, so whoever has applied this algorithm to have a goal node, so this path will be given. So this is the simple search tree algorithm. Our next topic is uninformed search. So this uninformed search is the particular condition in which we will have a problem. In that problem, we will be having a starting node and also goal node. So we have to search for that goal. So that means there is no, there can be multiple paths present in that particular one. So I will try to go from S to G. So this from S to G I have to go, and I don't have any information. So let's say this is a problem. This is a search space. In this one I am having source node, and here some goal node is there. So in the problem domain they will be giving, so the goal node is like this, and also the starting node is like this. So we don't have any other information, that is so the other information can be, so whether this particular we can go from S to G using this path. So there is no particular statement. From S, let's say I am having so three neighbors are three successors. So for this one I have to, if I selected some, let's say this is called A1, this is A2, this is A3. So this is uninformed search because so there is no particular condition that if I select A1, then my goal is if I am this much nearer to the goal. So if I have selected A2, so I am this much distance is there from goal node to that particular A2. And also if I selected A3, so the distance between A3 and G is like this. So like that one, there is no special information will be there. So we have to go blindly. That is how a blind man can so roam around a room. So for him he don't know whether where to go. So if he want to go from one particular position to another particular position, so for that one he don't know anything. He will randomly take some steps and he will go to he will try to go to the goal node. So like that one, this uninformed search, so we don't have any additional information other than the goal node and also the goal node, and we will be given some problem definition. So based on the problem definition, we have to try to find for the search for the goal node in the problem statement. So this uninformed search is also called as a blind search, and in this search, for these algorithms we will be having move gen function, that is to know so what are the successor nodes for that particular node. So we will be having move gen function, and also we will be having a goal test function stating that that particular whatever the node it is goal node or not. So these two informations only will be there for this uninformed search algorithms. So using these things we have to plan for the so order or how we can execute so that we can get the goal node. So these things will be differentiated, and these based on the selected algorithm. So the procedure will be different. So in uninformed search algorithms, in this unit we are going to see so depth first search, that is DFS, and breadth first search, that is BFS, and also depth bound DFS and depth first iterative deepening. So these four are the uninformed search algorithms we will be seeing in the unit 1. So for this all the algorithms we will be having so a problem graph will be there. In that graph we will be having starting node and also goal node will be there, and also we will be having a strategy so that based on the algorithm, so we will try to get the particular goal node using some condition. So this condition will be stated in the strategy. So how we are going to traversing the particular graph so that we can get to the G. So it will be coming from this strategy. So this strategy will be different for these four algorithms. And also a fringe will be there. A fringe is nothing but it is a whatever the data structure I am going to use in these algorithms. So these algorithms can be using different data structures. So we will be so they can be stated using this fringe. So after graph, strategy and fringe, we are having tree. So this tree is the after completion of the traversing. So the result will be shown in the tree. That is how we are going to the goal node G. So from from the starting node. So I have to go from the starting node to goal node. After I have traversed from the starting node to goal node, so it will be represented using this such tree. And also we will be having the path or solution plan or solution path. So this path will be given. So from source node and to goal node. So what are the intermediate nodes to go to the goal node? So those can be shown in the solution plan or solution path. So these are the elements that are presented in the uninformed search, and the algorithms we are using for this in this uninformed search are depth first search, breadth first search, depth bound DFS, and depth first iterative deepening. If we have completed these four topics, then the first unit will be over. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.